Your AI has learned from the entire internet. But does it actually know anything? The difference between remembering and truly understanding is a single Python script. Today, we're not just prompting an AI. We're giving it a library card to an expert's brain. Before we jump in, subscribe, comment below, get your coding vibe for today. Large language models are incredible, but they have a critical flaw. They can hallucinate, generating answers that sound plausible but are factually wrong. To build truly reliable AI applications, we need to ground them in a source of truth. That's where this incredible GitHub repository, B7 Leon, MLE-Flashcards, comes in. It's a curated knowledge base of over 200 expert-level flashcards on machine learning. Today, we'll build an AI-enhanced knowledge assistant using a technique called Retrieval-Augmented Generation, or RAG, to make our AI smarter, faster, and hyper-accurate. The github.com/b7leon/mle-flashcards repository is an open-source goldmine with over 200 flashcards on ML, computer vision, and CS. Created by B7 Leon, it's an expert-curated knowledge base. In our script, we treat this repository as a trusted source of truth, using a Retrieval-Augmented Generation pipeline. This grounds our AI in verified facts, transforming static cards into a dynamic tool that boosts. We're using vibe coding to get this done fast. We gave Gemini a simple prompt describing our goal, an AI knowledge assistant that uses RAG with simulated flashcard data. We asked it to build the retrieval functions, the Gemini API call, and the main interactive loop. Subscribe to get the full prompt and build it yourself. First, we set up our environment. We import the necessary libraries and configure our Gemini API key, which we securely load from an environment variable. We then initialize the Gemini 1.5 Pro model, getting our AI brain ready for act. Next, we simulate our knowledge base. In the real world, you'd parse the flashcard files, but here, we create a list of Python dictionaries representing the core concepts. We then define a simple retrieval function. This function mimics a vector search by performing a basic keyword match to find the most relevant flashcard content for a user's query. Now for the core AI logic. We define a function to interact with Gemini. This function constructs a detailed prompt. If we found relevant flashcards, we embed that context directly into the prompt, instructing the AI to use this information to form its answer. This is the augmented generation part of RAG. Finally, we create the main application loop. This code prints a welcome message and continuously prompts the user for a question. It calls our retrieval function to get context, then passes the query and context to our Gemini function to generate a response, which is then printed neatly to the console. Type exit to quit, and there you have it. We've transformed a generic LLM into a specialized ML expert. By grounding our AI with the curated knowledge from the MLE-Flashcards repository, we get answers that are not only faster but significantly more accurate and reliable. This is the key to building powerful, trustworthy AI agents. If you want to build this yourself, check out the code in the description. Don't forget to like and subscribe for more AI coding projects. Did you vibe code smarter today?